Hi, this is Fredrik Wermling again. Thanks for watching this video. Now I'm going to talk about analyzing CRISPR screens using ChatGPT. And as you know, this is a series of videos where I discuss different tools that can be used to analyze CRISPR screen data. I've already started this discussion with ChatGPT so that we don't have to wait for everything. So I'm just going to go through it. I started by telling it that it should pretend that we haven't discussed this before, because of course it's learning from you to some extent, and I don't want it to look different when you run this than me. So I ask it to pretend that it doesn't remember an analysis we've done in the past. You don't have to do that though, most probably. So you can start here. And I usually like starting sort of by not giving too much information to ChatGPT. Of course, you can use other chatbots, LLMs. So I usually like to not give too much information to start, to sort of have a little bit more unbiased approach. So I paste this gene and ask if there is a pattern in them, and so you remember these are the positively enriched genes that came out from the A549 data from DepMap, which there's another video when I discuss that. Looking at this list without context, here are some clear patterns that jump out. So there's tumor suppressors in here. Subset is strongly enriched for loss of function drivers in cancer, which makes then a lot of sense, right? mTOR TCS complex, DNA damage and cell cycle checkpoint, cytoskeletal adhesion, signaling scaffold, and then some other mixed categories, right? And these are, as you've seen in other videos, although I don't use this data set for all of them, you see that these are things that have been popping up when we do other type of pathway analysis. Then I sometimes go in and give a little bit more context to ChatGPT and see if that sort of changes anything. So here I say that this is RNAs that were enriched in a CRISPR screen experiment from DepMap with the A549 cell line. And my approach using CRISPR screens and the way we're doing it in my group is often trying to find drug targets and to sort of identify genes related to diagnostics. Could we find genes that if you knock them out, the cells are not doing very well? Well, then those might be interesting drug targets. If you, on the other hand, find drugs that if you knock them out, the cells sort of thrive and expand, then those could be diagnostically interesting, right? Especially if these are hits coming out, for example, from a setting where you added a drug to the cancer cells, or some more complex setup where, understanding that, for example, if you add a drug, cells with a particular genotype are enriched, then that could be a biomarker, that could be a diagnostic that should be sort of included when adding that drug to the patient. But here is a less complex screen, right? So it tells us that P10 TSS 1 and 2 all restrain mTOR C. So their knockout enrichment implies that cells benefit from elevated mTOR C. Therapeutic angle here, or therapy angle, they should be sensitive to mTOR pathway inhibitors, so Rapalogs or other versions, AKT, PI3K inhibitors also suggested here. And then it suggests some biomarkers that one can look at to see if these pathways are modified. Hippo fits, this NF2 knockout enrichments fit with lifting hippo restraints. It suggests then FAK inhibitors and sensitivity, and some biomarkers, P53, P21, USP28, DNA damage surveillance, so enriched suggesting disabling the G1 checkpoint is advantageous. Here it sort of suggests some inhibitors, and then other suggestions here. And then it starts coming with some suggestions for drugs that could be tested, and now we're starting to get into sort of validation of screens. And I think this is working really well to ask ChatGPT about sort of look at this gene set, are there any drugs that perhaps could be interesting to test here? It wasn't super clear to me what the diagnostics suggestions was here. And again, I mean, ChatGPT or any of these sort of chatbots, LLM-driven chatbots it's a discussion, right? I mean, you just ask questions basically. So here it was a little bit unclear to me what it was meant with diagnostic ideas. So I asked it to highlight that. And it's saying, related to this, the PI3K mTOR axis, loss of these genes lead to hyperactive mTOR C, so it's sort of suggesting, for example, phospho-S6 and phospho-4-ABP1 reflect mTOR activity. So this could be sort of a diagnostic to see that you have a cell that has this activation. It digs in here a little bit. You can pause and if you want to read more about this. It suggests that CCL4 could be measured in serum or in the tumor. Could be interesting. So here it's going through such things. And then I also like to use these sort of prompts if there's anything that's surprising here, because of course, especially when we have a dropout screen like this, or just a early late time point in the cancer cell line, especially in the cancer cell line that's very commonly used for different things. A lot of these things are known, right? I mean, the essential genes that drops out, etc. And I think it could be worth asking if there's something that's surprising here, because especially if you're working in sort of an academic project, you might want to focus on things that are not the most obvious, right? That people already worked on. So I think this could be a good prompt here. So this zinc finger transcription factor has sparse literature in cancer. It's not widely reported. And of course, these sort of things, if people haven't worked on it, could also be an indication for that it's not true, right? I mean, you need to validate hits in CRISPR screens. They are unfortunately not 100% validated, all the hits, right? I think it's an interesting prompt there, basically. So, and then it says here what's not surprising. So a lot of these are classic tumor suppressor, checkpoint regulators, etc. Yes, put myself here. So with that, I showed you a little bit how you can work with LLM-powered chatbots like ChatGPT and just have a discussion about genes and sort of, here's a list of genes, do you see something? Is there something that's novel? And of course, you know best yourself what's relevant for you to ask. But I think going forward, and I don't think this is a unique take, but of course, these type of tools like ChatGPT will probably more and more used for these type of purposes. And in fact, a lot of the sort of tools that I've showed you in previous videos to use for CRISPR screen analysis actually could be done directly by ChatGPT. There will be a video after this when I show you how to use ChatGPT also for writing some scripts to do gene set enrichment analysis. So that's another application where maybe ChatGPT isn't, at least at the moment, doesn't seem to be able to do this analysis completely by itself. You can ask it to write code, and I'll show you how that can be done even if you have very little experience. So with that, I thank you for watching. I hope you learned something, and I wish you a great continuation of the day. Bye.